Now let's continue the analysis over the trap handler in RISC-V based Linux kernel. Let's know that the trap handler in RISC-V based Linux kernel is handle exception. The thing to do in the handle exception is to store the set of general purpose register at the moment of the trap. And the next thing to do is to read the value of supervised course register as written in pseudocode. Based on the exception code value from supervised course register, different function calls can be made based on the value of the supervised course registers. This box indicates function table that is registered in the RISC-V based Linux kernel. So the function call to this function can be made inside the handle exception label. Let's suppose that the memory abort occurs in Linux kernel. In this case, the exception code will be 15. Depending on the value of the exception code, as explained, different call, the function call is made. In this case, call to do page fault is made. And then after do page fault, die function will be called. Inside die function, we will call another necessary API inside die function. As for print module, it will display the install the module device driver in the kernel. As for show RG, this function is to print the set of general purpose registers at the moment of the trap. And then the panic API will be called to invoke the crash. Now let's look at the part of the save context label that is jumped from handle exception. Another important operation is to read the control this register. As you can see, the supervisor exception the parent count register will be copied onto S2 register. This register is stvar. So stvar register may contain the faulty address when running the assembly instruction. As for supervisor exception parent count register, it contains address of instruction that caused the exception. As for this assembly instruction, the value of the supervised course register is copied onto S4 register. So once this value will be copied to this register, that this value of this register will be stored onto the stack area. So this operation can be done to store this important value at the moment of trap. Another important thing is to read the highest bit of supervised course register. If the highest bit is 1, it means that trap happens because of interrupt. For in this case, call to do IIQ function is made. Otherwise, it will access the exception, the function, the table, to call the corresponding the exception function. So this operation can be specified in this assembly block. So this is assembly routine, and this is the corresponding the entry.s code. So if you compile this code block, you're going to see this assembly instruction using this assembler. So if you look at this routine, this symbol indicate the start address for the exception vector table. This label, this symbol is start address to contain the different exception the function that could be observed in the later slide. Now it's time to analyze this label. This is a symbol, and this symbol only contains address for individual function. So if you look at the contents inside this symbol, you can see those kind of symbol of the function.